I'm just going to talk about multiplication of power series. So let's say I want you to find the first three non-zero terms in the Maclaurin series. For the function e to the x sine x. So the function I'm looking at is a product. It's e to the x times sine x. And remember, if we do our table, we're going to use the product rule. When I use the product rule here, the first time I'm going to get two terms. And then each one of those is going to give me two more terms and two more terms. So we definitely don't want to do the table, right? That's the one thing I hope we can all agree on. In theory, you took Calculus 1 before and passed it. I don't want you to just sit there and spend a bunch of time taking derivatives. It's kind of, I don't know, not the point of what we're trying to do here. So it's made up of, this function is made up of two pieces. It's made up of e to the x and it's made up of sine x. So let's start by writing down their Maclaurin series. So e to the x I've written down a few times. N equals 0 to infinity. X to the n over n factorial. And I'm going to write out some of the terms here. 1 plus x plus x squared over 2 factorial, or x squared over 2. X cubed over 3 factorial, or over 6. And now let's write down the Maclaurin series for sine of x as well. So I got to look that one up because I don't have it memorized. Okay. The sum, n equals 0 to infinity. Again, this one is on your list that I gave you earlier. 2n plus 1 over 2n plus 1 factorial. So let's write out some terms here. Okay. So plug in 0, it's going to be positive x. Plug in 1 minus x cubed over 3 factorial over 6 plus x to the 5th over 5 factorial. I don't know what that is. Plus dot, dot, dot. Okay. What I want to do is I want to multiply these two together because my function is the product of these two functions together. So I want to take and write e to the x times sine x. And to get that, I need to multiply these things together. Five factorial. Yeah, 5 factorial. Plus dot, dot, dot. Okay? Addition and multiplication are very nice operations, but they don't really work that well together because remember, when you multiply and you have an addition, you have to, like FOIL, distribute everything. So every term here on the left needs to get multiplied to every term on the right and vice versa. That makes it really hard to come up with the formula in general, which is why this question only asks for the first 3 non-zero terms. Okay? Because finding the formula in general is going to be very difficult. You have to multiply a lot of stuff out and combine like terms to get it to work out. So let's look at what's here. And if I multiply, what's the smallest power of x I can get? to the first. How can I get x to the first? 1 times x. Is that the only way I can get it? Is there any other things I can multiply to get x to the first? No. Okay. So our first term, it looks like it's a coefficient of 1, so I'll just write x. That's my first term, is x. Okay. Now what's the next power I can get here?
X squared.
X squared. How can I get x squared?
X times x.
X times x. Okay, great. Do you see any other way to get x squared?
No.
No. Plus x squared. Okay, what's our next power we can get? X to the third. How can I get x to the third?
X squared over 2.
X and x squared. So I get, don't do that. Get x and, sorry, you said x squared over 2 and x.
And then you can get x to the third over 6 and the 1.
And the 1. So there were 2 ways that I could get that one, right? Plus, so it said it was minus x cubed over 6 times 1 plus x cubed over 2. So you would simplify that, x plus x squared, and then this will become plus 1/3 x cubed. So those are my first 3 non-zero terms. But let me tell you, you can kind of already see, as you go up in powers, it's going to get harder. There's going to be more ways that you can get them. Like if I ask for x to the 7th, there's 3 ways you can get an x to the 7th. You could do an x to the 6th over 6 factorial times x. You could do x cubed and, x to the 4th and an x cubed. And you can do an x squared and an x to the 5th. There's 3 ways you can get that, right? Going on and on. So in general, when you're multiplying these together, if you're trying to multiply them together, I would try to like make a chart, like a multiplication table kind of thing that you're doing. So depending upon your goals, you're gonna, like for me, I want the first 3 non-zero terms. So I would take some of these terms here, like, I don't know, 1 plus x squared over 2 plus x cubed over 3. And then you would have more stuff here, but I'm going to write plus ... And then in the next power series, or the Maclaurin series, it was x, and I line everything up, x minus x cubed over 6. And then I would multiply these together, like do a multiplication table. So multiply x, you would get to everything in the first row, x plus x squared plus x cubed over 3 plus x to the 4th over 3. Sorry, over 2 is what that should have been. Over 2 plus, and then multiply minus x cubed over 6 times everything in the first row. So it would have been minus x cubed over 6 minus x to the 4th over 6, and so forth. No. Depending upon how many terms, if I wanted 5 terms, you need to make sure you've included enough terms so that when you add down, you would have the first 5 terms. So here I only needed the first 3 terms. And so this would be good enough for me.
How'd you get the 1/3 x cubed?
So you simplify 1/2 and a minus 1/6.
Okay.
Right? Get a common denominator.
Okay.
1/2 minus 1/6. The common denominator is 6.
Okay.
2/6 or 1/3, yeah.
Okay. Because you're adding them, you're not multiplying.
Yep, you're adding them. Yeah. You multiply to begin with, but then you add.
Okay.
So if it helps, make this chart and multiply. But in general, multiplying these Maclaurin series, it's very complicated just because of the whole nature of foiling and distributing is going on. And so products become a lot harder. Finding a formula in general when you're multiplying is much more difficult. Okay, yeah, I have time. So the last thing I wanted to talk about was reindexing series. And this is pretty important because in your homework, they're going to want the sum, when you write a series, they're going to want it to start off at 0 or start off at 1, whatever. And maybe what you have written down doesn't match up their starting point. And so I'm going to start with just, let's say we have our geometric series here. Let's say I take 1/2 to the n. This represents 1/2 plus 1/4 plus 1/8 and so on. And let's say now instead of 1, I want it to start off at 0. For whatever reason, I want the sum to start off at 0. So what have you done? You've decreased the number that you start off with, right? The number I put in is now 1 less. But you want to keep this balanced because you want to have the same numbers appearing. So now I'm plugging in a number smaller. So what I need to do is you're going to replace the label n. You're going to add 1 to it. Okay? So what you should do is replace n by n plus 1. And whenever I'm reindexing, whenever I'm relabeling my indices, I always double check. I plug in the numbers and make sure that it starts at the same place that the original one did. So if I plug in 0, I get 1/2. Plug in 1, I get 1/4, 1/8, and so forth. So these two series, they are equal. They're the exact same series, but the first one starts off at n equals 1, and the second one starts off at n equals 0. Okay? And in general, if you had n equals, like if you had n equals 2 there, you wanted to go down to 0, you would replace n by n plus 2. Okay? So how do I do this? I did it for a series, but how do you do this for a power series? So let me do one more example and then we'll finish. Let's say I take the power series for e to the x. And same thing, if you want this to start off at 0 now, you do the exact same thing. Replace n by n plus 1, but you do it everywhere there's an n. Okay? So x, this will be x to the n plus 1, and then n plus 1 factorial. And these two things are going to be the exact same. And you can write out terms to see that if you need to. These are exactly the same thing.
If you started at like n equals 2, would it be like n minus 1? Would you do that? Or?
Yeah. It would be n minus 1. So however much you're changing one way, then you do the opposite change with your labeling of your variable n. Exactly.